And welcome back. As we go ahead and continue talking about arrays, let's go ahead and talk about how privacy leaks work with array instance variables. So let's first start this off by revisiting this concept of accessors. Previously, we explained why it is a compromise of privacy for a class to have an accessor or any other method that returns a reference to a private mutable object. As noted when we talked about that, an accessor method should instead return a reference to a deep copy of a private object. Now, at the time, we had in mind returning the concept of a private instance variable of a class type. However, this same principle applies equally well to private instance variables of array types. And that's going to get us into some privacy leaks that we're going to have to address. So suppose that you want to have an accessor method for an array instance variable in the class partially filled array, which we've already looked at. Well, you might be tempted to define the accessor method as follows: public double array, get inside array, and then return A. This is a little bit problematic, and as we've indicated, it has a problem, which in this case, the accessor method allows a programmer to change the array object named by the private instance variable A in ways that bypass the checks that are built into mutator methods of the class partially filled array. If we want to really see why this is true, suppose we added this definition of the method get inside array to the class partially filled array and then consider the following code. Partially filled array, leaky array equals a new partially filled array 10. Double array, array name equals leaky array dot get inside array. The variable in this case, array name, and the private instance variable A now contain the same reference. So, because they have the same reference, both array name and the private instance variable A name basically the same array. Using array name as a name for the array named by the private instance variable A, we can now technically fill the index variables of A in any order and need not fill the array starting at the first element. This really kind of violates the spirit of the private modifier for the array instance variable A. For this reason, the accessor method get inside array should return a deep copy of the array named by the private instance variable A. We don't want to be pointing things to the same reference. Remember, that's a shallow copy. We don't want that with arrays. So let's look at a safer version of how to do that same accessor method. So if we look here, we have public double array, get inside array. Okay, so that the header here is still the same. But when we look at the inside, we have double temp equals new double max number of elements. For int I equals I is less than max number of elements, I plus plus, temp of I equals A, return temp. Notice here, we're not pointing an array reference directly to an array reference of another thing. We had the same thing when we had class types. Remember, we can't point a class type directly to another class type because it updates the reference. Because arrays, remember, have a specialized class type, this is the reason why we have to actually go through each of these individual elements and update them this way. And that gets us back to this idea of how we dealt with classes and copying constructors. If a private instance variable is an array type that has a class as its base type, well, then you need to make sure that copies of the class objects in the array when you are making that copy of the array. The copy constructor should make a copy that is completely independent of the array instance variable, that is a deep copy, in the same way that the accessor method does. So to illustrate this, we have a toy example class here that is using the date class for its instance variables. And in here you can see we have private date A, which of course is simply just a private object of the date class. It is an array of dates. And so here we say, okay, public toy example int array size, and we can say A is equal to new date array size, for I is less than 0, I is less than array size, I plus plus, A of I equals new date. So this right here, of course, is simply just a constructor. And then we have another constructor which takes in a toy example class. And down here we have a public date get array date. So this is very similar to what we just saw with our problematic array. However, if you notice in here, we are creating a temp variable, and that temp variable is going to allow us to make sure that we are creating deep copies of our code instead of shallow copies. And we can say, of course, here's our loop that sets the temp variable equal to the date one, and then we return temp. Now, of course, we can add additional methods into here, but just to illustrate the properties that we're trying to get across here with the shallow versus deep, I think this is a great thing to kind of take a look at. Again, when you're dealing with deep copies with arrays, you're going to want to take this approach where you're always going to have some kind of temp variable that's going to store whatever's in that array and then be able to update it with a for loop. Because if you don't do that, again, you're going to have with shallow copies and you're arrays are going to end up pointing their references at each other, and that's going to lead to problems down the road.